think we're almost here. 8:03. We'll start in a minute. Let me share this. The slides are same as yesterday. So hopefully you guys already have them. If not, let me share the slides. Today we're going to understand 4 topics: error handling in JavaScript, hashing passwords, input validation using Zod, and relationships in Mongo. Let's see how many of these we're able to do. Let me paste a link to the slides in chat. There we go. Those are the links to the slides. This is something we went through yesterday as well. If you are joining today for the first time and you skipped yesterday's class, most probably today's class will be a little hard for you. So I would strongly suggest you drop off right now only and go to yesterday's class and then watch this one later on, because everything from here to here we have already covered yesterday, probably here to here. Today we are discussing some improvements. What we built yesterday was how you build, a to-do application really quickly and deploy it and wait for that job offer, but it never comes. Today, we'll go through some of these improvements that are, bare minimum for you to have, and, the obvious red flags in the approach that we had yesterday. And how can you fix them? In the process, we are going to learn about some new things. For example, how do you do password hashing? Our Node.js server crashes from time to time. How can you make sure it doesn't crash? We may not do this today, but this is something you should do. Our to-do application is very rudimentary at the moment, adding some more endpoints in there. Adding timestamps. Okay, this one also we can ignore for now. Relationships in Mongo and adding validations using Zod. This is what we're going to cover today. Let's start off with a poll as always. How many of you already know all of this? How many of you have already, done this in the past? You understand, probably Zod is a difficult thing here or whatever, How many of you already know this? Not a lot. 71% don't know this. So we'll try to keep it slow. We'll probably just cover 2 to 3 things amongst many of these today. Then we will call it. The last thing, maybe I can, 1 or 2 things I can record offline as well. But let's try to finish all of this week. Cool. Let's kick things off by recapping yesterday's project. So to begin with, I would want you all to, number 1, have a MongoDB database. Number 2, understand the code from yesterday. If you don't know either one of these, do not continue in today's class. You will feel overwhelmed. Go through yesterday's class, then come to this class. Okay. 2 things you need to know. Number 1, this code you should understand. The code that is present on slide 1 at the top, this is something we coded yesterday. You should understand this code, only then proceed. This code is the backend of a to-do application with a database. What is this code? This code is the backend of a to-do application that we have written in Node.js using Express. And we also connect to a MongoDB database to store our data. Harkirat, what is a database? We discussed yesterday. You should go to yesterday's class. It's a place where you store all of your data. That is what is called a database. We have not written the front end for it. This will probably be an assignment, but we should also write the front end for it to be a foolproof to-do application. What I'm taking you through in the next 5 minutes is all the code that we wrote yesterday, all the backend that we coded yesterday. That includes authentication, that includes storing data in the DB. These are the 2 things that we did yesterday. Authentication we covered last week, we implemented again this week. The thing that we discussed yesterday was storing data in the database. Whenever a user sends you a request to, let's say, create a to-do, I repeat, whenever a user sends you a request to create a to-do, we actually create that to-do in our database. We persist it somewhere. What is this code that we wrote yesterday to do that? Let's try to look at it. If I open the code over here, it has 3 files. It has an index.js file, db.js file, auth.js file. Ignore all the other files for now. Index.js is our main file where we write most of our Express logic. If I open index.js, you will notice at the top, I am importing Express. Express is our HTTP framework. Below it, I am requiring something from ./db. What is this ./db? This is the code that is written in db.js. So the big thing we learned yesterday was not how to write all of this express logic. This we have already written in the past. The big thing we learned yesterday is what is this Mongoose library and how can you use this Mongoose library to connect to the database? How can you use this library to connect to a MongoDB database? That is what we learned yesterday. To do that, number one, you have to define your schemas and models. What do you have to define? Your schemas and your models. Harkirat, what is a schema and what is a model? A schema, as the name suggests, is the structure of your data. Over here, if you look at the db.js file, just focus here, ignore every other file. In this db.js file, number one, I require an external library called Mongoose. As the name suggests, it is a MongoDB related library. What does this library let you do? This library lets you create what are called schemas. What is a schema, Harkirat? Okay, what is the final structure of my data? We have the user's information. As more and more people come and sign up on our website, we will be storing their data in our database. One section of this data base will have our user's information. Let's say this one right here. And then one section of our database will have our to-dos information. We will have two separate databases or two separate tables more specifically, or what are called collections. Two separate collections we will have. Here we define the schema of the first collection. Here our user will have a name, an email and a password. And the special thing about their email is that their email ka type to string hi hai. It is of type string, but it needs to be unique. We need to make sure you're not putting the same email twice. That is what this schema is. And then we have a to-do schema, which describes here we will be storing our to-dos here as well, but they will look something like this. They will have a title, go to gym. Let's say that's one of my to-dos for today. Eat food. Let's say that's another to-do for today. Whether or not this to-do is done, whether or not I have marked it as completed. That is what this done field here means. The important thing was the user ID. Whenever I am storing something in this to-dos table, I am also storing which user does it belong to. My users table will eventually have a bunch of entries. User 1, their ID is 1. Their name is Harkirat. Their email is whatever. That will be my first entry. Then I will have another entry with ID 2, name Raman. And let's say they also have some email ID over here. I have two entries in my database. My users collection has two entries, entry number 1 and entry number 2. My to-dos collection, let's say, has one entry. Okay, there is a to-do with the title go to gym that has been made by the user ID 1. What is this second field over here? It is, okay, who is this user whose to-do this is? Which user does this to-do belong to? That is every entry in the to-dos table. Every entry in the to-dos table sort of has a what's called a foreign key in SQL tables. If you have heard of it, if you have not, you can think of this like a relationship. Here user ID actually points to something in the users collection. And that is exactly what we've written over here. Okay, we have a user ID, a title, and a whether or not this to-do is done. This is how you define your schemas. Once you have defined your schemas, you define your model. What is the model? Where am I storing this in my MongoDB database? Eventually, we saw this thing called MongoDB Compass. We saw this visualizer of our database. I can visualize my database over here. I can see the database that I am creating. Let's say I create a fresh database here called todo-app. Then this to-do app database of mine has a users table, and let's say it has a to-dos table. These are the two tables that I have. These are the two collections that I have. The name of this collection is what we put over here. The name of this users collection is what we put over here. So users is something put over here. To-dos is something put over here. So we know क्या ये जो user model है, the thing that we're going to insert the data from needs to go to the users collection. यहाँ पे this to-do model we're going to use very soon. It needs to send the data over here to this to-dos collection. That is what the first argument is. Second argument is कि schema क्या है? What does the structure of the data look like for this model? So what do you do in Mongoose to recap? What have we done in this file? We described the schema. We described the models. We exported them from here. One weird thing you might be seeing is this object ID. And this object ID is nothing but whenever you add any data in MongoDB, even if I add data manually, I click on insert document, it shows me that the default ID is this. It's a very weird format. As you can see, 66EF has some format. Every unique ID in MongoDB is an object ID. This is what is called an object ID. And whenever we will be creating entries in here, for example, title, go to gym, and done, let's say false. Whenever we create entries over here, the ID field over here is of type object ID. If I insert this, you will see the ID field is of type object ID, which is why यहाँ पे we say क्या जब आप to do बनाओगे ना, when you create the to do, it is going to refer an ID in the users table. User भी तो ऐसा ही होगा. The user will also look like this. They will have an underscore ID, which is an object ID, and they will have their own information in there, like their email, their password, so on and so forth. So this is an entry in my users table. If I go to the to-dos table, I want to say कि यार ये to-do जो है is of this user. And इस user की ID क्या है? It is object ID. It is not a string basically. The type of this is not a string. The type of it is not a string. It is an object ID, which is why यहाँ पे भी I have said कि यार जो to-do है, whenever I create a to-do, it will have a field called user ID, which will not be a string, but be a object ID. And I can paste that user's object ID over here. So that is why I say over here, user ID is object ID. Cool. This is the extra thing we learned yesterday. We exported these models from here. And then we used these models in our index.js file. In our index.js file, I imported these models at the top. Along with Express, I imported these models. I called mongoose.connect with my database credentials. Harkiyat, what are database credentials? Where can I get them? You will have to go to yesterday's class. I put my database credentials over here. I put the connection URL over here. Harkiyat, what is connection URL? Yesterday's class. And here I say if whenever a user is signing up, I get their email, password, and name. And I insert this in the database. Whatever I did when I went to the users collection, clicked on add data and started to add data. Whenever I click on insert, what happens when I click on insert is the same thing that happens whenever user model.create is called. So when this gets called with a certain email, password, and name, the same thing, as this happens, an ID is given by default, and email, password, and name is what the user sent to us when they hit the sign up endpoint. Do we understand this much? Let's do a quick poll. Itna recap ho gaya. Sign up endpoint is good enough for us to understand what to do next, and how to proceed. We understand this. Great. Sign up, we understand. So I would assume sign in also we understand. Okay, here user sends us an email and a password. We take this email and password. We check, is there an entry in the database with this email and password? And if that is true, then we do token generation, something authentication. Let's forget about that. Let's just focus on this much part for now. Okay, here I put an entry in the database. Here I check whether or not this entry exists in my sign in endpoint. But what is the problem over here? I don't know how many of you guys saw, but recently on Twitter, a lot of my and a bunch of other creators' passwords were leaked. I repeat, recently on Twitter, someone put up a bunch of passwords of mine and some other big creators. And my password was this. I can share with you. It is like very publicly available. The password is 19558 Gmail. It's my dad's service number back in, Indian Air Force. So this was my password in a lot of places. How did this get leaked? How did that person figure out that Kirat's password is this and put it up on Twitter? Because this password was leaked in a security vulnerability. There are many websites in India. For example, Big Basket is one. Paytm is one that have been hacked in the past. I think even an academy was. I could be wrong. What do I mean that they were hacked? I mean, उनका जो database credential था, their database credentials got leaked. If my database credential, this password that is present in this connection string gets leaked, then people can snoop in here and see कि अच्छा Harkirat's password on this website is 123123. Or mine is, let's say, my password that I used everywhere was this. Some other creator had something like I love Mansi or something like that. I totally forgot some woman's name. So this is where things get a little weird. Okay, if my password is stored in plain text, I repeat, if my password is stored in plain text over here, then that is a problem. If you are creating a website today in India, your own website, big basket, Paytm, whatever you are building today, when your user signs up, do not store their passwords in plain text. In a few countries, this is also illegal. Why? Because number one, people repeat passwords. If my password is I love Mansi here, most probably my Facebook password is also this. Most probably my Google password is also this. So, number one security issue, the developer of this company, whoever works at Big Basket, will open the database and figure out कि अच्छा, my ex-girlfriend's password is this over here. So my ex-girlfriend's password on Facebook is also this. And they will go to Facebook, log into their ex-girlfriend's account. That is bad. So number one, if you are the CTO of a company, you shouldn't trust your employees only. Your employees will go over here and start to see data and start to find their, ex-girlfriend's password. That is bad. Number two, let's say there's a data breach and your database gets leaked. Then everyone's plain text password is leaked to the world. Everyone all around the world can see that Harkirat ka password was this. My password was leaked in a very similar way. Similar logic applies to phone numbers, addresses. Everything of mine was leaked because of the same reason. Okay, I have placed a few orders from Big Basket in the past. Those orders were stored in a database. Now, of course, if this database is leaked, all of my Big Basket orders, address, everything was there, including my password. What are we trying to fix today? Password. What should you do if you are creating a backend today and storing users' username and password in here? You should hash this password. You should do what? You should hash this password. If the password that the user sent was I love Mansi, then you should convert it into some unreadable format before it is actually inserted in the database. You should not insert plain text passwords ever in a database. You should hash them. Harkirat, what is hashing? We have discussed a little bit in the Web3 cohort. It's a one-way conversion. It is not encryption. Hashing is different from encryption. When you hash, it is a one-way conversion. यहाँ से ये बन गया. You can't go back from here to here ever. You can't predict the original string easily. There are ways to predict the original string as well, but those ways are computationally infeasible. You have to brute force a lot. We'll talk a little bit more about, whether that is possible or not. But hashing, the algorithm itself says it should be one way. If I love Mansi is the user's password, if the user signs up on your website, if this is your backend, this is your backend, and this is your front end of, whatever todo-app.com. Then whenever the user sends a request with their email and their password, whatever I love, let's say Kiara, then this password should be hashed before it reaches the database. I repeat, what should happen over here is their plain text password should get converted to some random string, and the database should only have this random string. Inside the database, you should store the username. You should store this hashed password. You should not store the plain text password ever. Okay? Do we understand this? Okay, this should not be done. I would assume that is the case. We will do a poll very soon, but let me share one more problem that you might be thinking of when this happens. When the user signed up, I repeat, when the user signed up, you did this. You did not ever store their password in the database. You hashed their password. Their hashed password was stored over here. What happens when the user signs in? I repeat, in the future, user will come to the website. The user will sign in and they don't know you hashed their password. उनको थोड़ी पता है. They to have these credentials only. They will send you these credentials. How will you compare their original plain text password with the password that is stored in the database? How will you compare this and this? How will you check that this password is indeed correct for this user? Can you guess? You can just rerun the hash, right? Whatever was the hashing algorithm that converted this to this, run it again. Again, convert I love Kiara into the same hash. And then compare the hash over here with the hash over here. So when the user signs up, convert their password into some random looking string, very long string, hash their password. What is hashing? Given this, if your database ever gets leaked, the hacker can only see this. कि अच्छा email was this and password was this weird thing. Ab I can't, from this weird thing, I can't predict their original thing. So their original password, it can never be predicted, even if your database is, leaked somewhere, the passwords are hashed. And how will sign in work? When the user signs in on your website, they will send you the password. आप same चीज फिर से करोगे. You will still convert this into a hash, and that hash is what you will compare with the database. कि यार ये hash और ये hash अगर same है, because hashing is deterministic. I love Kiara will always lead to the same hash. So just convert it again, compare these two. Do we understand this? Do we understand the importance of hashing passwords before storing them in the database? We understand this. But there is one small problem in this approach as well. Can you guess? There is one small approach in problem in this approach. What if we have two people in our database, two entries, Bill at Microsoft.com. Can you guess who that is? That is Bill Gates. And then Harkirat, random person at gmail.com. And you see, KR, their hashes are the same. Which means what? Which means their passwords are the same. What did I say? Hashes are deterministic. अब अगर Bill का password is also I love Kiara, Harkirat's password is also I love Kiara, then doesn't that mean okay, you can just call Harkirat and say, bro, please tell me your password. If you tell me your password, I will be able to figure out Bill Gates's password. So it is a good thing that hashing is deterministic. It is a good thing that I love Kiara leads to the same output always. But what is the downside over there? The downside is if two people have the same hash, that means their password was the same. If you can figure out the password of this guy by calling him, by messaging him, by some other way, then you can figure out the password of Bill Gates. We need a way to make sure कि यार अगर password same भी है, even if the passwords of two people are the same, their hash is different. That is what we need to figure out. We need to ensure that even if Bill Gates and Harkirat have the same password, their hashes are different. How can we do that? Can you guess? Here comes the concept of salting. What is the concept we are learning next? We are learning the concept of a salt. What is a salt? When you have a very big sabji, dish, when you have a very big dish, what do you sprinkle in there? Small salt you sprinkle in there. I repeat, you sprinkle salt in small quantities in a very big dish. That is what a salt is in the real world. And similarly, in the context of password hashing, salt is the following. Given the backend and given a user that is signing up with, let's say, the credentials harkirat@gmail.com and whatever, 123, let's say, simple. These are their credentials. What you want to do is, क्या ठीक है, their password was 123123. I repeat, their password was 123123. But I will hash it with a salt. I will add a random salt after it. Let's say, some random string, something like this. 8xsi, some random, string that I generated. I will take their password. I will take a random salt. Some salt I will add to this. And this is what I will hash. I repeat, this is what I will hash. Let's say this hash outputted something like some random string like this. This is what the output of the hash was. I will store this hash in the database. I will store kyar harkirat@gmail.com has this password, and I will also store the salt. I will store kyar inka hashed password to ye raha. Their hashed password is this. Their salt is this. These are the two things I will store in the database. What did I do? I did not convert just 123123 into a hash. I added some salt on top of it, the salt being a random string, and I hashed this. This hash I put in the database. And what else did I put in the database? I put the salt that was used in plain text. इस salt को तो मैंने plain text में ही store कर दिया. I store the salt in plain text. I stored the hashed password over here. And can you guess what happens when Bill Gates comes with the same password? If Bill Gates signs up with the same password, I will again generate a salt for them. I will take the password, which again, they are dumb enough to have their password as 123123. But I am smart enough to now generate a random salt for them. And when I hash this, will it be the same as this? 123123 will be hashed to the same string. It is deterministic. But what am I hashing now? 123123, some salt with it. This salt is different here. Salt is different here. So the final output will be different. What will be stored in the database now will be Bill Gates' username and this password, which is different from this password, and the salt used for Bill Gates. So even though both of them have the same password, the final password stored in the database is different. If a hacker comes and hacks this website, they will look over here, they will look over here, they will be like, password to alag lag rahe hain. The passwords look different. Even though the passwords are the same, even though the password is 123123 here, 123123 here, what is stored in the database is different because we added a salt. That is the whole point of a salt. Can you guess how the sign-in endpoint would work now? What will the sign-in endpoint do? You will send it some data. It will check, let's say, the sign-in endpoint. Bill Gates is trying to sign in back into the website. Bill Gates will send the right credentials. What will the server do over here? It will first bring the salt into the database for Bill Gates. Sorry, into the Node.js process. Okay, what was the salt for Bill Gates? It will figure out which salt was this. Then it will take the password that Bill Gates gave during signing in. ये password कब आया है? During signing in. Added the salt to it. And then it will just repeat the process, right? It will convert into a hash and then compare this hash with this entry in the database. So it will first get the salt, then add the salt to the password, convert it into a hash, compare this hash with this hash. If they're the same, that means Bill Gates sent us the right credentials. Do we understand the concept of salting? How do we add salt to a password to ensure that the final output is different, the final hashed password is different, even if two people have the same password? We understand this 94%. So the only thing that is left is implementation. So can we start to implement this? How does the code look like for this? How can you create a salt? How can you hash the salt and the original password? How can you convert it to this guy? What do you store in the database? You can have your own naive implementation as well. If you guys are in the Web3 cohort, you might have heard of SHA-256. SHA-256 is a popular encryption algorithm. Sorry, popular hashing algorithm. If here I pass 123, 123, it spits out some random string for me. So we can have our own implementation like this as well. We have already in the past, given a string, spit out an output like this in the Web3 cohort at least. We can have our own implementation, or there is a very popular implementation of this, which has the concept of salts inbuilt. That implementation is called bcrypt. We can also uh, go through the bcrypt algorithm and use it. Either one of these is fine. You can implement your own logic to randomly generate the salt, add the salt to this guy and store it. Or if you don't want to use SHA-256 yourself, there's a very popular password hashing algorithm called bcrypt, which is what we can use. So why should we hash passwords? Because it is a technique used to securely store passwords in a way that make them difficult to recover or misuse. Recovery ke problem kab aayegi? If you are an employee. Misuse if it ever gets leaked, or vice versa, whatever. You get the idea. Instead of storing the actual password, you store a hashed version of the password in the database. What is a salt? A popular approach to hashing passwords involves using a hashing algorithm that incorporates a salt, a random value added to the password before hashing. A random value added to the password before hashing the password. This prevents attackers from using pre-computed tables to crack passwords. Do we know about rainbow tables or pre-computed tables? Basically, if you did not have the concept of hashing, if you did not have the concept of salting, sorry, then someone might have a very long pre-computed table. Kya, for the password 123123, the hash looks like this. For the password I love Kiara, the hash looks like this. All popular passwords, they might have pre-computed a what's called a rainbow table, or some table where all of these passwords are, or all of these hashes are already stored. So to avoid कि अगर आपका database leak हो गया, if your database is leaked and you did hash the passwords but you did not use a salt, तो क्या हुआ कि वो compare कर लेंगे इस rainbow table में कि यार is there a commonly used password that hashes to this, and if they find one then they'll be able to figure out कि ठीक है your password was, let's say 123123. So what is a rainbow table? What is a pre-computed table? यार if you don't use salting, अगर आप एक random सी looking string नहीं डाल रहे हो, people are dumb and people will use common passwords. 123123 is a common password. 123456 is a common password. So you can create a pre-computed table like this, जहाँ पे आप store कर लोगे कि this one hashed becomes this one hashed becomes this. And जब भी database leak हुआ, whenever the database gets leaked, even though you hashed, since you did not salt, आपने salt नहीं किया था, तो hackers will be able to compare the hash in this rainbow table and figure out कि अच्छा, you used 123123 as the password, which is why you need salting. The other approach I already shared, if me and Bill Gates have the same password, then salting will help us differentiate our passwords. Cool. What is bcrypt? Bcrypt is a cryptographic hashing algorithm designed for securely hashing passwords. Bcrypt incorporates a salt and is designed to be computationally expensive, making brute force attacks more difficult. What does it say? It incorporates a salting algorithm. Salting as a construct is present in this algorithm and is designed to be computationally expensive. देखो ऐसा नहीं है. You can always, even though hashing is one way, I repeat, hashing is supposed to be one way. If you give 123123, the output that comes out, let's say, is, some random string. Even though this is supposed to be unhackable or irreversible, you can still brute force everything, right? If there are, let's say, only 20 million inputs that are possible, तो तुम you can brute force कि अच्छा, what was the password? It was this. ठीक है. Does 123 leads to this? No. Does 123 leads to this? No. तो you can technically, if you have a super computer, आप सारी strings पे जाके हैश कर करके देख लोगे. वन का आउटपुट ये है, ओके, टूज आउटपुट इज दिस, ओके, थ्रीज आउटपुट इज दिस. You can try every string possible to reverse this. Even though hashing is irreversible, if you have a supercomputer that can calculate all the strings as output, you can compare the output and brute force कि ये output कौन से input पे आता है. You can brute force कि what output, this output comes on which input. So what does this hashing algorithm say? It says it is designed to be computationally expensive, making brute force attacks more difficult, almost impossible. कि मतलब you hash it so much it's almost impossible for you to brute force the original string. But if you have a supercomputer that can literally find the output of every string in less than, let's say, a minute, then of course you can reverse hashes. But no one has that supercomputer, so it's very wo concept, up in the air concept. Hopefully that is clear. I'm just trying to explain the statement. Hashes are technically irreversible, but if you have a supercomputer, then sure, they are reversible. All right, we are going to start from yesterday's code and add code on top of it. So if you want to code along with me, you should clone this repository locally, and then we will go from there. And if you want to just watch that, that's fine as well. Let me go to a folder over here, cohort 3, and let me clone this project. For the people who don't know Git yet, I will try to put out a video very soon as well. But if you don't know Git, you can also just download this file, unzip it, open it in Visual Studio Code. Either is fine. I am just going to use Git to clone it. And I'm going to open this in Visual Studio Code. I already have some pre-written code, which thankfully all of you already understand. We checked in the beginning of this class. So what is step one I have to do? I have to do an npm install to bring all the dependencies to my code base. That includes things like Mongoose, Express, everything. And what is the other thing I have to do? Now I have to bring the bcrypt library to my code base. What do I want? I want to make sure that on the sign up endpoint, I don't store this password in plain text. I somehow want to hash this password and, not just the password, but the password plus the salt. I want to hash the password and I also want to store the salt in the database. These are the two new things I have to do. Number one, I have to generate a salt, hash the password and the salt, store the salt in the database. A few things I have to do over here. This is the change that we have to make to our code base. How can you do that? We are using the bcrypt library. As I said, you can have your own implementation as well. This is just the most popularly used library everywhere. So install the bcrypt library. You can check out its docs over here. How do you install the bcrypt library? npm install bcrypt. This is one library that lets you implement the bcrypt hashing algorithm. You can decide to use the bcrypt hashing algorithm, SHA-256, your own hashing algorithm doesn't matter. As long as it is a hashing algorithm, and as long as it is irreversible, technically or whatever, very hard to reverse, then that hashing algorithm works. Go to its docs and try to read through it. It will give you a few functions. When you have the bcrypt library, it has a function called gen salt. What is this function? Generate salt. What does this function do? It generates a salt or a random string, as you can guess, by running a very expensive operation number of times. I repeat, the argument that it takes over here, salt rounds, is basically how many rounds does a certain hash happen. So you can first generate the salt. You can also Depends on you. If you want to write your own, const salt equal to some gen salt function, you can do that as well. If you don't want to use the library, you can be like, no, I will have my own implementation of the gen salt function, which will generate a random string. I will write that code over here, okay, to generate a random string. You can do that. Or you can use the bcrypt library to do it. The higher this salt rounds function or number, sorry, this is a number that it takes as input, the harder it is, to brute force your password. Once you have the salt, you called bcrypt.hash. This is my password. This is my salt. Please, whatever you get back over here is the final hash that you can store in the database. I repeat, this is function number 1. It is a callback based function. It is not a promised based function. Hopefully we understand this. Just like we did fs.read file that took a function as an input. The first argument there was what? When we did a fs.read file, the first argument here was the path to the string or the path to the file. Second argument here was a function, air command data. Do we remember this? Similarly, this function bcrypt.gensalt takes how many rounds do I need to do? How expensive is it to generate the salt? And the function that will, finally have salt as the second argument here. Again, this is the error first callback. The first argument is an error. If there is an error, you should just log it, stop the execution. Most of the times, thankfully, there won't be an error. You will get the salt variable. Then you called bcrypt.hash, which, takes your plain text password, takes the salt, and again in the callback returns you the thing that you should store in the database. So you can either do both these steps separately, or you can simply call bcrypt.hash with the password and the number of rounds over here. And this will do both the steps for you. It will generate the salt also. It will generate the hash also. So you can either do this separately. Step 1, I will generate the salt. Step 2, I will generate the hash. Or you can call bcrypt.hash with your password, the plain text password, the number of rounds you want to run the salt for, and then you can store that in the database. Either one of these is fine. This is a simpler approach. This basically does both of these under the hood, right? If you look at this function implementation, it will just call this and this under the hood. It is just doing both the steps together. So can you generate your own salt? You can. Can you use the bcrypt library to generate salt? You can. What will we use? We'll probably use the bcrypt library. So this second approach, let's try to use. Let's try to open this on the left. Let's try to open this on the right. And let's try to bring this bcrypt library to our code base and try to implement it. Step 1, npm install, oopsie daisy. Npm install bcrypt to bring the bcrypt library to our code base. Step 2, import the bcrypt library at the top. Bcrypt equal to require bcrypt. And step 3 is what? Here, before I store the password, I need to const hashed password equal to bcrypt.hash. What inputs are we going to send? We are going to send the plain text password as the input. And we are going to send the number of times we want to run the salt round. How computationally expensive we want this to be? Let's say 5, not too computationally expensive. And then the third argument was a callback, but I think this works as well. I think you can, I think there's a promisified approach as well. Yeah, you can simply do this. You can go with the callback approach. That will also work. You can also go with the promisified approach where we don't have the third argument. We don't have the third argument where we get the data. We simply await on the bcrypt.hash function. Do you remember initially I said there was an assignment to promesify the fs function call? This was one of the assignments that we did in the past. Initially, we converted the fs callback based code base into a promisified code base. Similarly, the bcrypt.hash function exposes you both kind of functions. You can also pass in a callback over here. If you pass in a callback, it will give you the data there. If you don't pass it a callback, it will return you a promise. Bcrypt.hash will return you a promise. And you can just await on that promise to get the hash password. Let's try to log the hashed password. And rather than storing the password in the database, let's store the hashed password. Okay, that is all that we are going to do. You might ask, Hakiyat, where is the salt? I also had to store the salt in the database. So we're coming to that very soon. Until then, do we understand? Okay, Harkirat had just called a function called bcrypt.hash. That hashed the password. We are good to go. If you want to take this as a black box, you can also take this as a black box. You don't have to worry about what is happening. How is the salt getting generated? Simply call bcrypt.hash with a password. I think this the second argument can also be, it's an optional argument. Even if you don't send it, it will work. But in our case, let's make it, do some work. Let's make it a little hard to, brute force the password. But even if you don't send a password, as you can see, as soon as I removed comma 5 from here, it said await is not needed. There are 3 dots that come below this. When I have comma 5, it becomes an async operation. It's doing something expensive. That is why I have to await it. If I make this 0, if I remove the extra number of rounds, if I make it less secure thoda, I don't have to await on it anymore. It will hash like this immediately. What is a good idea? It is a good idea for you to make it slightly more computationally expensive to brute force. It is a good idea for you to hash it a lot of times so that whoever is trying to brute forces, uska dimag kharab ho jayega and trying to, reverse the string, which is why the second argument you should pass over here. What is the second argument? This argument represents कि कितना ज्यादा मेहनत करानी है आपको इस hash function से. How heavily do you want to hash? How iteratively do you want to hash? If this is a big number, then this will take a really long time. So it shouldn't be a very big number, but it should also not be 0. A number like 5 or 10 is good enough. Let's stick to 5 for now. Cool. I've put 5 over here. Let's see what the hashed password is. Let me run this application, node index.js. Again, this is the code that I've written. Let me try to send a request via Postman. Let me try to send a request via Postman to the /signup endpoint with some credentials. Let's say email is some random thing. Password is what? Password is 123123. Let's see what gets logged over here when I send this. The server crashed because my MongoDB credentials are incorrect. I have written mongoose.connect over here. For you guys, you will also see this. So, put your MongoDB credentials over here. I did not want to put mine on GitHub, which is why I removed this before pushing this to GitHub. I am now going to put my database credentials here. If you have your database, you should put your database credentials there. If you don't have one, then what were you doing for the last 2 days? Last 2 days, we were trying to create a database. So create a database for yourself. Get yourself a connection string and paste that here. Let me replace this with todos-app-week-7-2. This is my database name. This is my MongoDB cluster. Okay. Now let me try it one more time. Run node index.js. And if I send a sign up request, it says you are signed up. But what gets stored in the database? Let's see. If I refresh my database, there you go. We see a new table called a new database called to-dos app week-7-2, this one. If I go to users over here, notice the password. Such a complicated password. Is this 123123? Sorry, it went away, cancel. Do you see this long hashed password over here? This long hashed password is what is stored in the database. And the salt is actually part of this. You can't see it, but this $2b, this $2b is the version of bcrypt you are using. This $05, can you guess what this is? This is the number of iterations we ran. This is the salt rounds that we had called. 5 was the rounds, right? If I go back here, how many rounds did I pass over here? 5. That is also stored here. And after that, some initial, I think 16 characters over here are the salt. And then everything after that is your password. So I could have had a separate field over here called salt. मैं salt को separately भी store कर सकता था. If I have my own implementation, I will probably store salt separately. Or in this case, in a single string, I stored everything. Okay, these are the number of iterations that were run. And this is the salt that was there. And everything after that is the password. So that is how you hash the password before storing it in the database. Now, if this database is ever leaked, the hacker can do nothing. They can read through this, so this was the salt and this was the this thing, but they can't, reverse the password from it. Or it's like computationally infeasible for them to do that. If I go to the /sign in endpoint, what do I need to change over here? When the user signs in, what did we have to do? When the user signs in, we first have to hit the database to get the salt. If you remember, we discussed this a while back. Okay, when the user signs in now, when the user sends a sign-in request, we first fetch the salt from the database. Then we run the same algorithm again. And then we find the final string, compare it with the thing that is stored in the database. So we can write all of this custom logic. Or again, thankfully, since everything is stored in the same place, I repeat, since everything is stored over here in this very long string, bcrypt provides you a function. I repeat, bcrypt provides you a function called bcrypt.compare. यार compare कर दो. ये रही original plain text string. This is the password that the user sent me. This is the entry from the database. Spons.password. Please compare these two. Const password match equal to this thing. If the password is matched, then you can say the user is logged in. If the password is not matched, you can say user is not logged in. So what did I do? I सबसे पहले तो hit the database. यार ये email वाला user मुझे दे दो. Give me the user who has this email. If there is no user that has this email, then I can simply return over here, return and put a rest.json. User does not exist in our database. So if the user does not exist, you do this. If a user with just that email, note I updated the query. I am not sending in a plain text password over here. I can't compare the user's plain text password with this hashed password. It will always become different. It will always be different. This condition will never be met, which is why I only compare this much. Okay, email kaun sa user mujhe de do. Give me that user whose email is this. And then I compare the hashed password. Response.password is what? What will come over here? This hashed password is what will come over here. And the plain text password is what we put over here. The bcrypt.compare function will itself take out, how many rounds were run? Okay, 5. What is the hashing algorithm that was used? Okay, 2. What is the salt? Okay, this is the salt. And then the bcrypt.compare function will convert this password using these 5 rounds, using this salt to the final thing, and it will compare the final thing that pops out there with the final thing that is present over here. If it is the same, it will return you true, else it will return you false. So if password match, then you generate the token for the user, return it to them, else you send them incorrect credentials. We are just piggy banking on this compare function rather than writing all of that algorithm ourselves to, fetch everything from here and then extract the salt, extract the number of rounds that it happened, rerun this, whatever function was, bcrypt.hash function with a specific salt, and compare the strings ourselves. We can do that as well. We can extract the number of rounds from here, the bcrypt algorithm from here, rehash the original string using this salt over here, and then compare the output that pops out and this output, or just call the compare function, which will do it for us. Call the bcrypt.compare function. Let's see if that works. If I go to Postman and now let me restart it. I restarted it. I have already signed up using this user. We already saw the password was hashed. When I sign in using the same password, 123123, it returns me back the token. If I change the password, it returns me back the token again. Can someone tell me what is wrong here? Let's open chat. Who knows what is wrong over here? Wait, there you go. This function returns a promise. So you have to await it. Otherwise, this will always, if of promise is always true. So just make sure you're awaiting it and you're good to go. Sign in works. Let's do a quick poll. Now, if I send the wrong password, it says incorrect credentials. If I send the right password, it tells me my token. Can we do a quick poll? Is this good to go, guys? Do we understand password hashing? All right. 94% is great. That is the first thing 90% still great. I will do a doubt session at the end. Let's do one more thing and then we will call it hashing passwords. We understand. These are all the improvements you should do in your to-do application. This one we have done. There are a bunch of others. Let's do the simplest one, which is error handling. I'm sure some of you already know this. Okay, right now, our server crashes if you sign up using a duplicate email. I repeat, if I sign up, control reaches here, I try to do a user model dot create. But on my user model, I repeat, on my user model, I have put the constraints. Okay, the email needs to be unique. If an email already exists in the database, you should throw an error and let the user know you can't make this entry. So the code as such, if you have written code as such, what will happen is if I run my server, I start my server, everything is rosy daily, everything is fine. You send a request to sign up, the server crashes. Everyone who's on your website cannot access the backend. The server crashed literally. Why? Because this line of code threw an error. That error stopped the server. This will happen fairly often in your applications. If you know some function can throw an error, you should wrap it inside a try catch. I repeat, if you know completely all the body in here can throw an error, even though the whole body cannot, maybe this bcrypt.hash function will throw an error, or this user model dot create function will throw an error. So you know, code from here to here may throw an error. When it throws an error, our complete application stops, and hence you should wrap this inside a try catch block. Notice the syntax, it's a little weird. It looks like a function, but it isn't. This, isn't a function, the catch block at the end. This is the syntax of a try catch block. What does this try catch block do? Here, try running this code. And if there is an exception, catch that exception over here. And then feel free to proceed with the rest of your code. What does the try catch block do? It says you got the password. That is fine. You insert it in the database. That is fine. If everything works fine, cool. If there is an error, then don't crash the server, catch the error over here. So now if I run the code and send a request with a repeated user, the server doesn't crash. There is still a problem. I'm returning back message, you are signed up to the user. That is bad. User is not signed up. The server had a crash. I repeat, the server had a crash, not a crash. The server threw an exception over here, but we caught that exception over here. If I put a console.log here, user, error while putting in the DB. So this try catch block helps us catch an error. If I again send this entry, you will see a log error while putting things in the database. So even though this threw an error, it did not stop the application. The error was caught and this thing was logged over here. The question is, how can you send the user back a better response? How can you tell the user, okay, hey, error while, or user already exists, something like this. You want, okay, whenever the exception gets caught, you return the user this, and else you return the user this. You want something like this, right? You want, if an exception is caught, then you return this, else you return this to the user. You need sort of an if else over here, which is slightly hard to do. Let's see what this does. If I run this and click on send, you will see the server crashes again. The client receives user already exists. The control reached here. User got back this error, but the server crashed again. Why? Because I tried to resend the response. On a single request, you can only send back a response once, which is why, you need some logic like this. I'm writing a very ugly logic. There are like ways to do it better. But, let's say something like this. Error thrown equal to false. If the error is thrown, make it true. And make sure if not error thrown, only then you respond back to the user. Something like this. This is a bad way to do it. There are better ways to do it. What have I done? Put it inside a try catch block. If there is an error, log this. If there is no error, then log this, or return the user this. That way, your application doesn't crash. Harkirat, should I put everything in a try catch block? Ideally, or there are even better ways to do, exception catching in Express. But do we understand a try catch block? Do we understand? If you know some code is going to throw an error, how can you catch that error and make sure the server does not crash? Do we understand a try catch block? I think it exists in Java as well. So the Java people should be able to understand it, fairly simply. Hopefully everyone understands it fairly simply. Let's do a poll, Akash. What is throwing an error? Throwing an error is basically, this function, any function that is problematic, that can have problems like, okay, everyone understands 92% is great, or 90%. Any function that can be problematic. It returns you errors like this. The way to throw an error in JavaScript is something like this. Okay, whatever user already exists. So these functions user.create will, if you go inside the function, it will have some code like this that is throwing that error. And what are you doing? You are catching that error over here, so that if there is something wrong, you don't stop the server. You just catch the error and move on. Cool. People understand this. 90% is great. Then let's do one more. It's only 9:04. Let's do input validation really quickly. Yeah, that would be great. Let's do input validation using Zod. There is one other very ugly thing in our current code base. Let's understand how can you make this better. Let's first understand the ugly thing. The ugly thing looks something like this. Here, let me remove the try catch so that we can see the ugly thing a little better. Let me remove the try catch for now. So code looks something like this. Specifically, the sign up endpoint now has been reverted to the original thing. There is one small problem in our current implementation, which is we are not doing input validation. What are we not doing? We are not doing input validation. Let's do a poll. I want to have, should we proceed? Yes or no? Do you want to understand Zod validation right now? Yes or no? Okay, it is a yes. So you guys have the mental capacity to go on for another, let's say, 20 minutes. Great. Then in that case, let's finish this. Actually, you should have waited for me to ask the question. I wanted to make sure. Okay, I'm assuming it is you guys are good and half an hour more. All right. The problem here is, okay, the user can send us anything. We are not validating that. I repeat, the user, we expect them to give us what? A string. We expect them to give us a string. We expect them to give us a string. Can you trust the user? You cannot. User can give us anything. If I write node index.js over here, I start the server, the user can come to Postman and literally send me an object over here. Hacker, I have hacked. Something like this. I can. Password is an array. 1, 2, 3. You have created a backend. People can send any data to that backend. If they come on your website, I repeat, if they come on your website, let's say you have a website like this, where there is a sign-in form, you will think that they will only put in a username and password. But what will they do? They will come to your website, click on inspect, open the network tab, and be like, Acha, when I click on login, what request goes out? They will try to check that request. Acha, this is the request. This is the URL where it went out. And the payload somewhere had, email set to this and password. I don't see it here. Somewhere the password is also present over here. So they will, duplicate that request. They will duplicate that request and go to Postman, paste the URL over here, whatever that Facebook URL was. And rather than sending email the right way, rather than sending a string as an email, they will send a complex object. कुछ भी भेज देंगे. You can't trust your end user to send you even JSON data. They can send you random data, empty data, invalid strings, so on and so forth. So this is a very common, I won't call it an attack vector. No one does this, but they can. And your server should be smart enough to first check कि यार email string ही भेजी है ना? Is this a string? Is this a number or whatever, a string? Is this a string? Your server should check this. Your server should do what? Your server should do what's called input validation. What are we learning about in this section? We are learning about input validation. कि यार अगर string नहीं आई, if not email, let's say, dot is string, something like this. Let's say a function like this exists. और अगर string है भी, तो if not email dot contains @ of, अगर उसमें @ of ही नहीं है, then it is not a valid email. Or, if the email length is really small, you can add a bunch of input validation checks here. कि यार अगर email string नहीं है, या फिर even if it is a string, but it doesn't have @ in the middle, which means it's an invalid email, return right here. Rest.json, message, incorrect email. You should add all of these validation checks to the top of your route. आपके route के top पे सबसे पहली चीज जो check होनी चाहिए should be, has the user sent you the right things? If you are expecting a string which should have @ in the middle, which should have at least 5 characters in it, has the user sent it? If you're expecting a password which should be a string, should be at least 10 characters, should have one special character, should have one uppercase character, should have one lowercase character, are you checking that over here? If password dot length is less than 5, then return. You have a really small password. These are the things that you need to validate over here. You need to add what? You need to add input validation. Do we understand this? What happens if we don't? If we don't add input validation, and let me start the server, and the user wants to mess up with your database, they will send you something like this. Email में string की जगह they will send you something like this. If they send it, your server, where am I? Oh, I sent it to facebook.com. If they send you this, your server crashes. Why does your server crash? Because you try to put an object in the database, even though the thing that was expected was a string. So the end user could somehow mess up with your database. If you did not have very strict schema, अगर आपका schema बहुत ज़्यादा strict ना होता, over here we have strictly said कि email should be a string. But if we had like email can be anything, then the user would have been able to store an object in our database. हमारा object का, our database would started to have looked something like this. कि rather than email being a string, it would have become an object. So users can really mess up with your end data as well as your backend, unless you are doing input validation over here, unless you are validating whatever data they have sent, that is correct. That is what you expect. Do we understand the problem? Then we will get to the solution. And thoda I've already shared the solution. Okay, first do input validation correctly over here. But do we understand the problem at the very least? And the dumb way to solve it. Okay, if type of email is not equal to string, or email dot length is less than 5, or email dot includes @ is false. If it does not have @ in the middle, then return early over here. Return and tell them email incorrect. So this is one way to do input validation. I had to write a lot of code. It is very verbose. I still haven't added all the checks. I haven't checked कि @ से पहले कुछ होना चाहिए. There should be something before @. There should be something after @. I haven't checked any of that. So I will have to do a lot of checks over here to have real correct input validation. Even adding this much is a good start though, because now if I restart my server and if I go to Postman, if I send the request, if I send the request, it gives me a very clean response. Email is incorrect. If I try to send it anything weird, it will tell me. If I send it an email that is not an email, it will tell me email is incorrect. If I send it the right email, something that has an email like format, then it will sign me up. अभी कुछ problem हो गई होगी यहाँ पे. Password is incorrect. I sent an array. So, I need to add the password validation here as well. Just like I added email validation, I should add password validation. So many things I need to add to the top of my file. Do we understand this? Let's do a quick poll. Akash, if you're there, let me do that. Okay, we understand this. Now, what is the ugly way to do input validation? You do this. What is the easy way to do it? Care some library probably figured this out. Now, there is some library who has written a function like is string. If not is valid string email, then return. If not is valid string password, then return, so on and so forth. Why not use an external library that will do all of these runtime checks for us? What will it do? It will do all of these runtime checks for us. One such library is Zord, probably the only one that is used or I've seen used. What is Zord? TypeScript first schema validation with static type inference. Ignore what this is. Ignore what this is. We will come to both of these when we reach TypeScript. Schema validation is what we have to focus on, or more specifically, object validation, everything validation. Let's look at how can you do schema validation using Zord. How can you bring this library to your code base and start to use it? You can go through the docs, or let me, take you through how you use Zord in your project. You can also go through the docs and figure it out. They have decentish docs, introduction, sponsors, TS config. This is the docs. They use slightly different TypeScript syntax, which is why your might get boggled a bit. But basically, what is happening here, and even if you don't understand this, it is fine. We will rewrite the code. It is first importing the Zord library at the top. Specifically, it is importing a variable called Z, and it is saying, "Here, my schema is z.string. I want to validate whether or not my thing is a string." And then on this my schema, you can call my schema.parse Puna. That will return you Puna because this is a valid string. If you called my schema.parse 12, it will throw an error because 12 is not a string. So this is, a gist of this library. Let's try to write it ourselves. I know this might have gone through your head a little bit. What is step one? Step one is doing input validation over here. How can you do that? Bring the Zord library to your code base. npm install Zord. What do you have to validate? I have to validate कि यार ये जो rec.body है ना, this rec.body should look like this. It should be an object. It should be an object which has a key called email, which is a string. It has a key called password, which is a string. And it has a key called name, which is a string. That is what I want. I want कि rec.body. I could individually check these as well. कि email should be string, password should be string. Or I can say rec.body object should be this. कुछ अलग नहीं होना चाहिए इसको छोड़ के. User should not have even sent me something extra. Like, random 1, 2, 3. I don't even want that. I want literally their input to be completely valid like this. That is what I want from my end user. So you will describe this schema in a Zord object. When you know कि rec.body needs to look like this, the first thing you have to do is describe this schema in a Zord object. Let's see how to do that. First, you import Z, which is just an export. These guys have like a global export from Zod. You import Z from this library, and then you create your schema. You say const required body equal to Z dot object. What do I want? My required body should be an object which has email, which should be a string, which has name, which should be a string, which has password, which should be a string. You define the schema in a Zod object. This is probably the most difficult bit for you to digest right now. And eventually, when we reach type inference, that also gets a little hard in Zod. Other than that, Zod is nothing. Simple library. It just says कि यार जो तुम्हें validate करना है ना, whatever you want to validate eventually, create a Zod object from this. Create a schema from this. Let me know the structure of your data, which in our case, Z should be a string. And if you want, you can add more checks in here. A string with minimum length of 3 with maximum length of 100, that is an email. It gives you everything. It gives you very nice top level functions. Yeah, ठीक है. Tell me what do you want? You want it to be a string with minimum length 3, with maximum length 100, and it should be an email. Okay, I will validate it. I want the name of the person again to be, minimum of 3, maximum of 100. उससे लंबा नाम तो किसका होगा? No one will have a name longer than 100. If they are sending you a name longer than 100, if someone is sending you something like this, they're probably trying to mess up with your database. They're trying to store infinite data in your database. So, you should block them. You should right away say, we have a min and a max. And in our case, the maximum of the password is, let's say, whatever, 100. The name is 100, and same for, the password. The password probably needs to be a minimum of 3, maximum of 100. If you want, you can also add more complicated password checks here. It should have a single special character, things like this. I'll take you through that also very soon. Describe the schema. I have made it slightly complicated. If this feels complicated, this much also works for now. कि at least इतना तो validate हो जाए कि all 3 inputs are a string. And if you want to go a little complicated, add more constraints. कि a string with min 3, max 100, that has the email format at the rate of in the middle, some text before, some text after text should be a domain, things like these. Defining the schema is step 1. Step 2 is parsing the data. Const parsed data equal to required body dot. Now there are 2 functions you can use: parse, rec.body, or you can write something like this: const parsed data with success equal to required body dot safe parse. I'll share the difference between parse and safe parse very soon. But these 2 functions are all you have to write to validate your input. What is my input? Input is rec.body. What is my schema? Schema is required body, this variable that I've written over here. This is the required body. This is the input body. And ignore the first approach for now. Let's go to the second approach. This will return you 2 things. The safe parse function returns you 2 things. If you look at the final function output, it will show you something like this. If you did not understand what I did just here, don't worry about it. Basically, it will return you 2 things. You can destructure this object directly over here, success, data. Or if this feels complicated, just store it in a variable called parsed data with success. If parsed data with success dot success is true, then you are good to go. That means the parsing succeeded. If that is not true, that means the parsing failed. Something failed. Either the email is not a string with min 3, max 100 email. Either the name is not correct. Either the password is not correct. Something is not correct. If this variable has a success field which is false, that means you return right here and you tell the user message incorrect format. You stop right here. Otherwise, you know everything is fine. Otherwise, you know, yeah, this is actually a string. This is a password. This is a name. Do whatever you want after this. You have caught all of your errors early. You have done input validation in just 5 lines of code, whatever, 10 lines of code, versus writing so much custom logic to check KR is this a string, is the minimum 3, so on and so forth. You are relying on the Zord library to give it the schema first and then parse the user data using that schema by calling the safe parse function. You are not calling the parse function. There is a very subtle difference between both of them. You are calling the safe parse function. Let's see if it works. Then I'll share the difference between this and this. Then we can discuss more. There are like 3-4 things to discuss. Number one, how to show the user the exact error. If the user is on your website and they gave you a very small string password, let's say 123, they should see this. Acha, the password length is small. They should see the input error messages. If I ever go to any good website, whatever, let's say facebook.com, and I put just 123 over here, a warning pops up niche, okay, password is not safe, add a special character. If I add a special character, another warning comes, okay, please add uppercase. I add uppercase, so on and so forth. So how can I return to the user? Yaar, ye kami hai. These are the things that are missing. How can I tell them the exact errors? We'll discuss that soon. For now, let's see, does that work? If I do node index.js now and try to go to Postman, code is on the left. Postman is on the right. If I send a request with RNS data, let's say the email is an array. Does it work? It says incorrect format. If I say email is an object, does it work? Incorrect format. Let's say I make everything correct, but I add a third, fourth field here. This may or may not work. I say random 1, 2, 3. If I add this actually might work. It did work. So, if you have extra things, you can actually make this even more stricter by giving it some argument here. I don't know, strict : true. But for now, it is just checking these three, characters. If you give it something extra, it is ignoring it. Parsing still works. As long as these 3 input fields are correct, it is good to go. Zord does not fail. Even if you add some extra fields, it ignores the extra fields. But if any one of these is incorrect, name has a number rather than a string, it fails. If the name is really small, 1, then it fails. If the name is really big, more than 100 characters, then it fails. Only if everything is correct, name is between whatever 3 to 100 characters, email is actually of the email format. If I make this some non-email format, it will still fail. If I add a email over here, then it will work. Signed up. So what was I able to do? Correct input validation. How did I do it? I used the Zord library. What is missing? I should let the user know kami kya hai. I should let them know